Good afternoon, folks. Today you have a substitute, and you should have already turned in your homework from yesterday, which was page 569, numbers 1 through 7. So today I'm going to go ahead and take you through your notes for this 9-3, day 3. Today is Thursday, which means tomorrow is Friday, and Friday you will obviously have a binder check. And then we will be taking a quiz over this 9-3. So let's talk about what it means to be the zeros of a function. You all should know from our previous sections that a zero of a function is the same as a root, is the same as an x-intercept. So when they come out in the directions here and they say find the zeros of the function, they're actually just telling you to find the x-intercepts. So I'm going to go ahead and pull up Desmos, and I'm going to type in this function, and we're going to see where it crosses the x-axis. All right, so my first function starts with f of x. Remember, that's the same thing as y. So I can say y equals x squared plus 2x and minus 35. So if I take a look at this parabola, I can zoom out if you would like, but right here it shows me that my zeros, our x-intercepts, are -7 and 5. Meaning, if I plug those back into the original equation, they should make it equal 0. Okay, let's go on to the second one. New equation, y equals 30x squared minus 5x. So if I look at this parabola, it's rather skinny because of that 30 out front, and you can see my zeros are 0, and 1.6, that would be 1.6 repeating. Okay, so I have 0 and 1.6 repeating. And finally, number 3, if I go ahead and get that graph pulled up here, y equals 10x squared plus 13x minus 3. So it's looking like I am going to have to zoom out this time. My zeros are at -1.5 and 0.2. Okay, so remember what this means, folks. Those are the answers. That means when you plug them in, it will make them 0. Remember, we look for these x-intercepts because they are quadratics. They have a highest power of 2. Okay, let's recap some of the stuff that we've talked about previously. We've talked about a transformation. A transformation is a change in position or size. Specifically, a translation is when you simply move the graph, and you can move it left, right, up, or down, and those things are called translations. If a parabola is going to be moved vertically, that means that you'll have your squared part, and then you'll have some number on the end that's being added. That's going to mean it's going to be moved up. If you have some number on the end that's being subtracted, that means it's going to be moved down. If you have some number inside the parentheses that's being subtracted, this will be moved to the right. And if you've got some number inside the squared parentheses that's being added, it will move it to the left. Remember, this is the opposite of what you typically think. If we subtract it, we go to the right. If we add it, we go to the left. A reflection is when you flip your graph, okay? If it's a regular x squared, that means it's going to be face up. But if I make it negative, it's going to flip it to be face down, and that's a reflection. Then we have a dilation. A dilation is to make it narrow or wide. That's a dilation. If it is stretched vertically, that means there will be something outside in front of the squared term. Okay, if it is stretched, that means it's going to go from being a normal size to being thinner. Okay, and that happens when A is a whole number. It would be compressed if you've got this number attached to the squared term. If it's going to be compressed, it's going to go from a normal shape to being wider. It's kind of like it's being smushed. It's being compressed. And that's if A is a fraction. Okay, so what I would like for you to do in this next set of problems is take the graph that I've given you and tell me what the equation would be. Now I want you to notice that it says write a function, which means I'm going to start all of these with f of x. Okay, remember that the general form, the parent function, is just a straight on x squared. Okay, and you know what the graph of x squared looks like. It looks like that. The vertex is at 0, 0, and it is a normal width, and it has not been moved. So if I take a look at this first one, first thing I need to look at is the vertex. That vertex is right there. That vertex has been moved up from 0, 0. It's been moved up 2, which means I need to put a plus 2 on the end of this to show that it has been moved up. Now, if I take a look at how far away the next point is, if I start at this vertex and I go to the next nice point, it looks like it's right there. That is 2 units away, 1, 2 units away from the vertex, which means it's been stretched, which means there needs to be a 2 in front of the x squared term. Finally, you notice it is flipped upside down, which means there needs to be a negative out front. And we have our function for that graph. If I take a look at the next one, I've noticed my vertex has been moved down, which means I need a minus 2 on the end of this function. If I look at where the next nice point is, it's here, which means I have to go 2 units, 1, 2 units to get to that point, which means in front of the x squared term, there needs to be a 2. It has been stretched. And it is right side up, so it's going to stay positive. So my function for number 2 will look like that. In number 3, my vertex has been moved up 2, which means there needs to be a plus 2 on the end. If I want to look at my next nice point, that would happen way over here. Okay? If you look, this point right here is only a half a unit away from the vertex, a half a unit away, and it's wider. So that means I need to put a half in front of my x squared term. And that's flipped upside down, so it's going to have a negative in front of it as well. So that would be my function. Okay, looking at number 4, my vertex has been moved down again, which means I need a minus 2 on the end. If you take a look at how far you've got to go, that is a half a unit away, which means in front of my x squared term, I need a half. It is face up, so it does not need to be negative. And I have my function f of x equals 1/2 x squared minus 2. Okay, so I think the hardest part in all of this, folks, is trying to figure out what this a number is here. Okay, when you are trying to figure out that a number, and I'm going to go ahead and kind of get rid of this so I can re-explain a little bit. When I'm looking at that a number, I need to look and see if I go over 1 unit, away from my vertex, how far do I have to go to get to the next point? In this case, it's 2. If I go over from my vertex, how far do I have to get to the next point? In this case, it's 2. If I go over 1 unit from my vertex, I only have to go a half a unit for that one. And if I go over from my vertex, it's only a half a unit for that one as well. All right, moving on to the back here. This vertex has been moved down, which means I need a -1 on the end. If I move away from my vertex 1 unit, the next point is right here. That is 3 units. So there needs to be a 3 in front of my x squared. And that is an upside down parabola, so there needs to be a negative sign in front of it. This vertex has been moved up 1, so there will be a +1 on the end. If I move away from my vertex, the next point that I come to is there. That is 3 units away, so I need a 3 in front of my x squared because it was stretched. Last one in this section, here's my vertex. It's been moved down 1. If I move 1 away from my vertex, how far do I have to go? That doesn't quite look like a half if you ask me. So I'm going to call it a third x squared. And it is face up, so it does not need to be negative. Okay, so next section, you will see that every graph here has 2 parabolas on it. You need to use the graphs to write a function for g of x in terms of f of x. That means if I'm going to write it for g of x, all of these answers should say g of x equals, and then somewhere over here after this equal sign, you'd have to have an f of x. So if I look at f of x, which is this one right here, the first thing I need to know is how do I get to g of x? Well, if I look at this, it looks like g of x has been moved up 1, 2, 3, 4 units. This thing is up 4, so I know I need to do that. Now I also need to look and see if it got any wider. Well, if I go over 1, I go up 1. If I go over 1, I go up 1. So it did not change width at all. All it did was move up by 4. So my g of x is just f of x moved up 4. If I look at f of x here, it has been moved. It has been moved 1, 2, 3 to the left. Let's see if the width has changed at all. If I move 1 unit away, I have to move 1 unit up. If I move 1 unit away, we move 1 unit up. So the width has not moved. It's just been moved 3 to the left. So g of x is f of x moved to the left. Well, you all know if I'm going to move to the left, I have to be adding inside that parentheses. So my function would be g of x equals f of x plus 3. Number 3, here's my f of x. It's been moved. It's been moved down 1. Okay. It's also been moved over. So I go down 1 and I have to move over 1, 2, 3 units to the right. Let's check to see if it's the same width. If I move over 1, I'm 1 away. If I move over 1, I'm 1 away. The other thing I need you to notice is f of x has been flipped over. And you know how to flip things. That means we just have to make it negative. So I have g of x equals. We need to put the negative symbol out front. F of x has to go to the right 3, which means inside of here, we have to subtract. And then we also want to go down 1. So that means I need a -1 on the end. Okay, let's take a look at number 4. Here's f of x. First question is, has it been moved? Well, yes, it's been moved down 1. It was not flipped because it was already flipped already, but if you take a look here, this one has to be moved 1 unit over, 1 unit down. This one is 1 unit over, 3 units down. So this thing has been stretched by 3. So if I'm going to write a function for g of x, if it's stretched by 3, that 3 has to go out front. And if it goes down by 1, there needs to be a minus 1 on the end. Okay, number 5. Here's my f of x. It's gotten moved. This vertex gets moved down 1 to the left 2. Okay, let's see if the width has changed at all. This guy gets over 1 up 1. This guy's also over 1 up 1. So that width has not changed. All we have to do is move it. So g of x, if I'm going to move it to the left, that means I have to put a plus 2 inside the parentheses. And if it's going to go down, I need to put a minus 1 on the end. Hopefully we're getting the hang of this here a little bit. Here's f of x. That vertex was moved 3 to the right. It was also flipped. If you look at that parabola, it's been flipped over. Let's take a look at the width. In f of x, we're over 1, down 1. In g of x, it looks like over 1, up a half. So this has now been compressed by a half. So let's get all this in my function now. G of x equals, well, the first thing I have to do is compress it and flip it. And then if I'm going to move it to the right, I have to put a minus 3 inside those parentheses. Number 7, here's f of x. The vertex was moved up 3. It was flipped. And let's check the width. So from f of x, we go over 1, up 1. From g of x, we go over 1, down 2. So this has been stretched by 2. All right, so if I'm going to write my function, we've got to flip it and stretch it. Then we have to move it up by 3, which means that plus 3 goes on the end. Okay, f of x is here. Let's see where it's been moved. It's been moved, looks like, to the right 1. And it looks like it's been moved down 1, 2, 3, 4, 5, 6. It was not flipped. Let's check the width though. F of x is over 1, down 1. G of x is over 1, down 1. So we just had to do some moving here. So my function has to be moved to the right 1 and then down 6. All right, looks like we have one more left here, folks. Here's f of x. That vertex has been moved right 1, up 2. It has been flipped. And now let's check the width. In f of x, we go over 1, up 1. In g of x, we go over 1, down 2. So that means this thing has been compressed by 2. I'm sorry, not compressed. This thing has been stretched by 2. It got skinnier. So if I'm going to write my function, I need to flip it and stretch it. Then I may need to move it to the right 1, which means I'm going to subtract 1 in those parentheses, and up 2 means I'm going to add the 2 on the end. Okay, folks, that is your notes, or those are your notes for today. You will need to get a worksheet from the substitute. It is called the Who Am I Quadratics Worksheet. So go ahead and pause this video now and get that worksheet. And then I want to walk you through the very first one on that. So I'm going to go ahead and pull that up. Okay, so I'm looking for the Who Am I Quadratics worksheet, which is right here. And I'll zoom in a little bit. All right, it says, who am I? Parabolas. Identify all the possible answers for each clue. So if I take a look at the first one, it says my axis of symmetry is x equals 2. So if I go ahead and I draw in my axis of symmetries, which of them have an axis of symmetry of 2? Well, the first thing I'm going to do is I'm going to go through and draw my axis of symmetry in all of these. Remember, the axis of symmetry cuts it right down the middle. So if we look at these, which of these lines are on x equals 2? X equals 2 means it's over to the right 2. Well, letter A looks like it's to the right 3. Letter B is to the right 1. Letter C is just on 0. Letter D moves over 4. Letter E also moves over 4. Letter F is to the left 1. Letter G, that is x equals 2, so I'm going to put a G right here. Letter H looks like it moves to the left 4, and letter I, the axis of symmetry, is also on 2, so this is G and I. This says, in my equation, A is greater than 0. Well, you know that for a quadratic equation, it could be like that. So if the A is greater than 0, which is what this says, that means it has to be positive. Well, we know if the A is positive, it is face up. So this question is asking me which parabolas are face up. So I will write the letter of all of those parabolas that are face up. Okay. Next one says I have no zeros. Well, you all know what zeros are. Zeros are the answers. They're the x-intercepts. So if I look at these, which of these have no zeros? Which of them will never touch the x-axis? So hopefully you can see that this is how you're going to go ahead and do this worksheet. So I'll leave you to the rest of it. Tomorrow we will review and have a quiz over section 9.3.